To solve this root equation, I'm going to add the square root of x plus 1 to both sides of this equation, changing this to the square root of x plus 10 is equal to 1 plus the square root of x plus 1. I'm doing this because my next step is to square both sides. The left side will simplify nicely. It would just leave us with x plus 10, whereas the right side is a little bit more complicated. You do square the first term, and 1 squared is 1. You do square the last term. The square root of this thing squared is simply x plus 1. I'll put that at the very end. But unfortunately, you get 1 times the square root of x plus 1 twice, which is where this middle term of 2 the square root of x plus 1 comes from. Let's combine some like terms. Let's see, on the right, I'm going to write this as 2 plus x plus 2 the square root of x plus 1. I can now subtract x from both sides, and why not subtract 2 as well? Changing this equation to 8 is equal to 2 the square root of x plus 1. As I can divide both sides by 2, I think I'll do so in order to change the question to 4 is equal to just the square root of x plus 1, leaving me with one more step, which I will again square both sides. I'll square the left, I'll square the right. On the left I get 16, on the right I get x plus 1, and after I subtract 1 from both sides, I arrive at my answer of x is equal to 15. The only thing to look out for is potentially this could be an extraneous solution, so I'm just going to check that 15 works in my original equation. That is the square root of 15 plus 10 minus the square root of 15 plus 1, is that the same thing as 1? Is this true? That's the square root of 25 minus the square root of 16. Again, is that 1? This is 5 minus 4. Yeah, that's a true statement. 1 is equal to 1. X equals 15 is, in fact, a solution, not an extraneous one, and that is it for this problem. Parts A, B, and C of question 2 are leading you to answer an inequality at the very end, once you get a sketch of the graph. So to start this problem, before I even answer parts A, B, and C, you can put this thing into your graphing calculator. That's not a bad idea. Being careful with parentheses, but also you can factor this thing. The top is x plus 2 times x minus 1, all divided by, okay, that's going to be x plus 6 times x minus 5. Both of these equations will tell you where intercepts and asymptotes are located. Let's start there with, let's see, maybe the vertical asymptote, or asymptotes, the x-intercept. With the vertical asymptote, that's where the denominator is 0. There's 2 places. X is equal to -6 as well as x is equal to +5. And the x-intercepts, I grouped these two things together because that's where the numerator is 0, which is going to be at -2 and also +1 for both x. The other 2 pieces, which is going to be the horizontal asymptote and the y-intercept, those come from ratios of terms that appear within these 2 equations. The horizontal asymptote is the ratio of the numbers in front of the highest powered x terms. They're both equal to x squared with a 1 in front of them, so therefore y equals 1 is the horizontal asymptote. Whereas the y-intercept is the ratio of the last 2 terms, it's a y value, that's -2 over -30. That's a +1 over 15, a 15th, so some very small value. These will help us figure out the way the graph looks when I look at it in my calculator. Now part B asks another important question. Potentially your graph could cross over the horizontal asymptote of y is equal to 1. To answer this question, is it ever the case that the original function takes on a value of 1? This is a very easy equation to solve because you can multiply this entire denominator over to this side, changing this equation to x squared plus x minus 2 is equal to x squared plus x minus 30. any solution to this equation will be a place where the graph is equal to the horizontal asymptote. But I'm noticing that on both the left and the right side of this equation, I can subtract x squared, which means they cancel. And likewise, there's a plus x and a plus x, which cancels as well. The equation becomes -2 is equal to -30, which is a false statement. And what this means for part B is that the graph does not equal or even cross the horizontal asymptote. So, I mean, I guess for B, the answer is really no. This does not happen. This is important when it comes to answering the inequality. So, one thing to consider is, I knew the answer was going to be no. I knew I was going to set the top equal to the bottom, and they both had an x squared and an x, and I knew right away that they would cancel. So if you can see that ahead of time, it'll save you a little bit of work. Okay, so for part C, I now want to sketch a graph of the function, so I'm going to bring in an x and a y axis to do that. All right, let's sketch these things from parts A and B onto the graph, starting with the, let's see, I guess the vertical asymptotes. One is at -6, which I'll put here. Okay, -6, there we go. I'll label it, as well as x is equal to +5. That's another vertical asymptote. My x-intercepts are at -2, 0, as well as 1, 0. I have a horizontal asymptote at 1. That's a y value. Y is equal to 1. And I have a y-intercept. It's a really small number, but I still want to mark this on my graph, even though it doesn't show up very well in my graphing calculator. I know it goes at some place that's above the x-axis. The other important thing is when I go to sketch this graph, I know there's going to be a portion over here, and they will never equal y is equal to 1. Therefore, it always stays above this line. This is great. Here's what my graph should look like. I should see a portion over here. Looks like this. There's going to be a part in the middle that goes through those 3 points, approaches my asymptotes. And then there should be a piece over here, again, always above y is equal to 1. Here's a sketch of my graph. And the final part to this question is, can you use this graph to solve a pretty difficult inequality? Where is x squared plus x minus 2, all divided by x squared plus x minus 30? Where is this greater than 1? According to my graph, here's y is equal to 1. That's going to be every x value where the graph is above this line. That's this piece and this piece. I'm going to shade that in. I want to refer to this portion of the graph. This is where the graph is strictly greater than 1. And the corresponding x values are here and here. It's our job to write down what those x values are. It's -infinity. I do that every time. All right, that's -infinity up to, but not including -6, as well as everything from 5 to +infinity. That's referring to this spot and this spot. And that's the answer to this question. So for question 3, we want to find the inverse of one of these functions. So one of them is, in fact, 1-to-1, and the other is not. So on the left here, we have the graph of f of x, which is this cubic function. And is this thing a 1-to-1 function? The answer is no. There's a lot of ways to answer this question. But I see this line here. This is a horizontal line that goes through the graph more than twice. This is not 1-to-1. This means on the domain of this function, there is no inverse. But if we compare this to the graph of g of x, which is the cube root of x plus 2, if I look at this one, every horizontal line that I draw is only going to go through the graph once. You only get this one point of intersection. There's a one spot here, here, and so on. You never get a multiple intersection point. This means the graph is 1-to-1. Therefore, I can solve for g inverse of x. It must exist on the domain of this function. To figure out what it is, and this is part B, I'm not going to find the inverse for f of x. It doesn't exist, but I can for g of x. I need to find the inverse of the cube root of x plus 2. I'm rewriting the function as the cube root of x plus 2 with a y in place of g of x. If I switch out the y with the x and the x with the y, this thing, in fact, is the inverse. The goal is to solve this equation for y. It's pretty easy to do. I can cube both sides. That gives me x cubed is equal to, cubing a cube root cancels it, leaving me with x plus 2. I would then subtract 2 from both sides, and I get x cubed minus 2 is equal to y. This is the inverse for g of x. I'll put that over here. G inverse of x is the formula x cubed minus 2. This is the function given by f of x in question 4. You can put this into your graphing calculator. It might be a nice thing to do to check your work. But our goal is to factor this thing. And the way we're going to do this is by looking at the graph and first identifying if there are any zeros that are integers. And I'm claiming there should be 2. I can see them pretty clearly. There's one here as well as one here. That is x is equal to -4 and x is equal to +1. Might not be a bad idea to put this into your calculator and type those two numbers into your table, and hopefully you see 0 as the y value for these two spots. There's this other one here, something between 0 and -1. If we could guess that thing, it'd be very easy to factor this equation. But, all right, we at least have answered part A. Part B is, well, what are two factors of this polynomial? Using the above information, one would have to be x plus 4. That has got to be a factor of this polynomial, and the reason is, if you put -4 in place of this x, it makes the factor equal 0. That's the connection between a 0 and a factor. Likewise, over here, x minus 1 is the factor corresponding to the 0, 1. All right, so we're very close to being done. I just need one other factor to completely break this polynomial apart. Well, what is it? In part C, I say you could use polynomial division if that is necessary. So I think I'm actually going to take that approach where I'm trying to factor this thing. I'm going to divide x minus 1 into the original polynomial. So I'm going to put down x minus 1 has got to divide into 3x cubed plus 10x squared minus 9x minus 4. It's got to split this thing apart perfectly. Let's see. I want to cancel 3x cubed, so I'm going to multiply by 3x squared. That gives us 3x cubed minus 3x squared. And when I take the difference of that, being careful to change this to addition, I get 13x squared minus 9x. And I'm going to multiply by 13x. That gives me 13x squared minus 13x. And when I take the difference, being careful to, I'm actually subtracting a negative, which is addition. I get 4x minus 4. Okay, I see that this is going to work. I get 4 multiplied to x minus 1 is 4x minus 4. And I get a remainder of 0. This is perfect. I took my original polynomial, which was 3x cubed plus 10x squared minus 9x minus 4. I factored out x minus 1, and I had 3x squared plus 13x plus 4 left over. I now have to break apart this last polynomial. The x minus 1 is all set. I know x plus 4 has got to divide into this piece, and that would mean it's pretty easy to guess that the answer is, well, it's got to be a 3x, and it's got to be a plus 1. This must be the factorization of the polynomial that we start with. And if you want to just double check your work, this factor is equal to 0 at -1/3, and that is precisely this other 0 on my graph. It wasn't perfectly an integer, but it's a third of the way between 0 and -1. So it might not be necessary to do this work over here if you can guess this final factor, but if you're having trouble doing that, you could either divide x minus 1 or x plus 4 into this expression and then factor apart something that is smaller. For question 5, I'm going to use the above formula to determine the balance of an account where we're first investing $5,000 at a 4% annual interest rate that is compounded quarterly, which means 4 times. My formula is b of t is equal to 5,000 times 1 plus, okay, that's 0.04. We have to write it in a decimal, divided by 4 to the power of 4t. If I carefully simplify this, this is b of t is equal to 5,000 times, that's going to be 1.01 in the parentheses to the power of 4t. And that's part A, just getting the formula. And then part B is, well, what's going to be the balance of the account after 10 years? So what is b of 10? To answer this, I'm going to do this in a calculator. In place of y1, I'm going to plug in my formula exactly like this. All right, let's see what we get by going to the table and putting 10 in place of x. All right, I get approximately, I'll round it to 2 decimal places, but the value I have in my table is $7,444, and it just says 0.3. Technically, it's, when I scroll up to it, 0.318, meaning I'll round it to 0.32. This is the balance of the account, $7,444.32. The last portion of this question is, once you have a formula, you can determine the balance after any amount of time, but what if you'd like to work backwards? That is, if I give you a balance, can you tell me the amount of time that it takes to achieve this value? And I'm asking for how long does it take this account to triple in value? Using your formula, you're asking, well, when is b of t going to be equal to $15,000? That's what we get if we triple $5,000. Said another way, you're setting your formula equal to 15,000. And clearly, if you divide both sides by 5,000, which is your initial amount, it'll cancel on the left. And on the right, you're going to get 3. If you say triple, it would be 3. If you said double, it would be 2. I'm completely okay if you just started here. Get rid of the initial amount, take your formula and set it equal to either 2 or 3 or whatever the question is asking for. If we're using logarithms, I'm going to apply log to both sides because it has this property allowing you to bring the 4t in front of your entire equation. I can now simply solve for t by dividing both sides by not only 4, so I'm using some parentheses here, but also log of 1.01. That's your exact answer. I'm going to type this into my calculator just to get an estimate. So let's see. Okay, that's log 3 divided by parentheses 4 and then log of 1.01. And I get, okay, it says 27.602. And I could, actually it keeps going, and this is a pretty decent answer. So let's see. How long is that? That's years, but we have to be a little bit careful here. Since we're compounding quarterly, you're not allowed to put 0.6024 into the decimal into this function. You're only allowed to go by quarters, which would be 0.25, 0.5, 0.75, and then back to an integer with a decimal of 0. So I look at this as, okay, if it were, let me see, if you had 27.5, that's 27 and a half years. That's not good enough. You have to go a little further. But the next amount of time that you're allowed to go is to 27.75, 3/4 of the way through a year. This technically is the answer. So, and the reason for that is we're going quarterly. So you could only use decimals that are either 0, 0.25, 0.5, or 0.75. And since this was between these two, it would have to be this one for the first time that the account triples in value. All right, so here we're going to sketch two transformations of y equals f of x, which is our given information. So we have two different sketches, and if I did this right, they're both going to fit in the window that I've provided. For the function on the left, 2f of x minus 8, I'm going to list out what this equation does. It does two things. Inside the parentheses first, it's going to go right 8 places. And the second thing it's going to do multiplication by 2. We're going to double whatever the y value is. Let's do that. Starting with this point here, if we go over 8 places, so this is 5, 6, 7, 8, we're right here at positive 3, the y value is 0, and if you double 0, it stays at 0. Let's do this for the remaining points. Like this one here, if we go over 8, the x value is currently 0, it's going to end up at positive 8. Now if we double the y value of 5, it's going to go up to 10. That's the final location of that spot. 8, 10. And lastly, this point. Okay, it's currently at 3. If you go over 8, it'll now be at 11. The y value is 5. If you double it, it goes up to 10. This is my graph. The whole thing moved over 8 places to the right, and then I doubled the y values. Let's try this with our other equation. I'm not changing any of the x's. This thing is only changing my y values. The first one is multiplication by -1. This is going to reflect the y values. It's going to reflect them over the x-axis. The -2 is going to go down 2, again, because we're changing the y values. Let's start with this point here. Okay, the y value is currently 0. And this equation says multiply that y value by -1. Well, 0 times -1 is 0. If you then subtract 2, you go down 2 places. We're finally at -5, -2. Let's do that for the remaining points. Like this one. Step 1 is to take the y value of 5 and multiply it by -1. It goes to -5. If you then subtract 2, it goes down 2 more to -7. Last one. Again, this has a y value of 5. Multiplying by -1 takes it down to -5. Subtracting 2 more takes it to -7. And this is the graph that I have. It's reflected over the x-axis, and it then is moved down 2 places.